Good evening, students. Mm, we already completed mm, Unit 1. Today we have to discuss about Unit 2. Okay. In Unit 2 there are operators, quantum mechanical operators. Operator means whatever in Unit 1 we did derivative integration. These are the operators. But how to use this one also you know in Unit 1. We already discussed it, and here we discuss about the operator and how we can write the operator. This is Unit 2. Okay, Unit 1 we already completed. Today we have to discuss about operator. An operator is a mathematical command. An operator is a mathematical command that tells us what to do on what. An operator is a mathematical command that tells us what to do on what. That means suppose I write 5 into 3. We know that answer is 15. This is called operator into, and this is operator operates these two functions, which is multiplication and converted into result 15. This is called multiplication operator. Similarly, if 5 plus 3 is equal to 8, this is operator. Plus is a operator, addition operator. So the two functions are same, 5 and 3. If we change the operator, result will change. Here 5 plus 5, 3. Two functions are same as like here, same is here. But here is addition operator, which is equal to 8. Similarly, if you take 5 minus 3, answer is 2. This is the operator. This operates in between 5 and 3. Both you see 5 and 3, both are the same number, but operator is different, multiplication. So if you multiply these two numbers, we get 15. If we add this same two number, we get 8. If we subtract these two number, we get 2. That means this is the operator which tells what to do on what. This multiplication operator tells multiply these two numbers. This addition operator tells us add the two number. This subtraction operator tells us subtract these two number. Okay, and this is the operator what we can read. Suppose in example, but in quantum mechanics what we do, suppose I write a cap of fx, where a cap is the operator. A cap is the operator. Here a cap means maybe integration, maybe derivative, maybe multiplication, maybe subtraction, whatever it may be. It is the operator. And fx is a function of x. Fx is a function. Fx is a function of x. Suppose I tell that fx is equal to 2x plus 6. And operator a cap is x. Then what is the function? A cap of fx. We can write a cap, instead of a cap I write x. Instead of fx I write 2x plus 6. Then you multiply. We get 2x square plus 6x. This is my answer. This is the operator which tells us that we have to multiply this x with this num function. We get this one. This is how the operator tells us. Suppose we know that Schrodinger equation h cap psi is equal to E psi. H cap, which is called as Hamiltonian operator, which is called as Hamiltonian operator, and psi is the wave function. Psi is the wave function. E is the total energy. E is the total energy. Then what is the Hamiltonian operator? If you take this one to this side, S psi minus S psi is equal to 0. S psi is the Hamiltonian operator. That means we know that dou by dou x, dou square psi by dou x, dou square psi by dou y, dou square psi by dou z. Dou square by dou x square, dou square by dou square, dou square by dou z square. So this is how the Hamiltonian operator. Hamiltonian is a mathematician. So in his name, this operator was named. So this is how in quantum mechanics there are certain fundamental operators are there. There are certain fundamental operators. What are they? Now suppose I write here operator, one table. Name is operator. Classical quantity, how we can write in classical mechanics. But quantity, how we can write. Quantum mechanical operator, how we can perform it. Quantum mechanical operator, how we can perform it. Suppose I tell that position operator. In classical quantity, suppose I tell that this is one of the particle which travels in x direction. That means here is the position. Suppose here I can write that it is x. In x direction it can travel. So what is the position it change? Now if position change from this position to this position, then we change that, the change of position takes place. In classical quantity we can write it as x. Okay, in x direction. That means in quantum mechanics, how can I write now x cap? Classical mechanics we write x, just like here we multiply x. Quantum mechanics we write s cap. That means if we s cap means multiplication by x in x direction. Similarly for y direction, suppose in y direction it can move from here is point, it moves from here 1y, so 2y, 3y, 3 into y times. So we can write in quantum mechanics y cap, and it is multiplication by y. Similarly for z direction goes above, we can in quantum mechanics we write z cap and operation, what that mean, multiply by z. Okay, this is called fundamental operator in quantum mechanics. What is the linear momentum operator? Linear momentum. What is the linear momentum operator? In classical mechanics, we can write px, that we already know. In quantum mechanics, I write px cap, and its value is minus IH bar dou by dou x. That means if px bar cap in quantum mechanics, we have to multiply with this value. That means minus IH bar, derivative of dou by dou x, whatever be the function here. they differentiate with x. Okay, similarly for in y, py in classical mechanics, quantum mechanics, we write py cap and its value is minus IH bar dou by dou y. Similarly for pz, here pz cap in quantum mechanics I write here minus IH bar dou by dou z. Differentiate with respect to z. In classical mechanics we can write this way, in quantum mechanics I can write this way, px cap, py cap, pz cap. Then we have to differentiate with each function with this value, and multiply with this one, multiply with this one, multiply with this one, and this is the operator. Multiply with dou by dou x, we differentiate, then multiply with IH bar, differentiate with dou by dou x, multiply with minus dou IH bar, here differentiate with dou by dou z, multiply with minus IH bar. This is how we can operate a function using the quantum mechanical operator. So these are the called fundamental operators in quantum mechanics. Then what are the postulates? That already you know postulates of quantum mechanics. Here also same way we can learn the postulates of quantum mechanics. It is present also in +3. Also you know this one. There are 6 postulates. If you go to the physics book, there are 5 postulates, but in in chemistry there are 6 postulates. Postulate of quantum mechanics. Postulates of quantum mechanics. Postulate 1, first postulate. The physical state of a quantum mechanical system, the physical state of a quantum mechanical system that means any quantum mechanical system you consider, that physical state at time t, any time you consider, any time t, 5 seconds, 3 seconds, 4 seconds, is completely defined described by the wave function psi xt, by the wave function psi xt. The psi xt depends upon this wave function psi xt depends upon the coordinate of the particle. Coordinate of the particle. This is possible. The possible information property of the system can be deduced from it. Whatever the possible information, can be deduced from it. Well, information can be deduced. Information can be deduced from it. That means what? Try to understand the physical state. Physical state matlab, suppose you consider water. Suppose this is my beaker. It contains water. Okay. Water, the physical state of water is in the liquid state. We call that it is in the liquid state. That means what is the physical state? The physical state is in the liquid form of a quantum mechanical system. Suppose I call this is a quantum this belongs to a quantum mechanical system. System means you already know that the specified part of the universe which is under experimental investigation. Suppose this is the entire portion on which we put a beaker. Suppose this is my round table on which I put a beaker, and beaker it contains water. What is the physical state? The liquid state. This is my quantum mechanical system. At time t, suppose at any time, suppose morning time, evening time, or night time, suppose in the morning time, suppose at 12 noon, it is in the liquid state. But at suppose in the night 11 p.m. suppose temperature drops, it converted to the solid. The physical state is in solid state. So it tells that the physical state of a quantum mechanical system, any quantum mechanical system, the physical state of the solid or liquid at time t, any time t we consider, morning 12 noon or 11 a.m. and the night 11 p.m. whatever may be time, is completely described by the wave function psi xt. So whatever be the physical state of this, of the solid, liquid or gas, or whatever its state, it is completely described, whatever the state of the system is completely described by this wave function psi xt. The psi xt depends upon the coordinate of the particle. That means coordinate matlab where it is present. Whether it is present, if in my laboratory in Odisha, in the 11 am it will not be converted into the ice form, it will remain in the liquid form. If we place it in the Srinagar to 11 am in the morning, it is converted to liquid state, but 11 p.m. in the night, it is converted to the ice form, temperature drops. So here coordinate means where it is present, position, depends upon the coordinate of the particle. So the psi xt, the function on which the state of the system depends, and this wave function depends on the coordinate of the particle, where it is present. It is present in Odisha, present in MP, present in Delhi, or present in Srinagar. Srinagar in the morning 11 am it is in the liquid state, 11 p.m. in the night it is in the solid state. So it depends upon the position. Similarly, suppose we put a graph. I tell that this is my temperature axis starting from suppose 0, here it is minus, negative, here it starts from the positive, here in the position of y-axis. Suppose I tell that the system I present here is in here, and suppose temperature is 2 degree, normal water, it is converted to the ice form. So where it is present, now what is the, suppose it is temperature, it is suppose pressure. Where it is present, the temperature is this much, pressure is this much, it is in the solid state. Or temperature is this much, pressure is this much, it is in the liquid state. So this is called coordinate, where it is present, coordinate of the particle. That already you know from the phase rule, already you know it is in the +3. what we know in the phase rule? What is the, suppose it is in the triple point, it is in the this form, suppose converted towards the origin, it is in this state, and it is in the aligned towards the pressure axis. You know that this is the triple point. When we go triple point means this is the temperature axis, this is the pressure axis. When this is the metastable form, when it is beyond, comes towards the, suppose I tell that what is the coordinate, this tells that the wave function, this is water system, wave function depends upon the coordinate of the particle. Suppose I tell that this is the coordinate of the particle, this is the temperature axis, this is the pressure axis, where it formed, and in this state water is formed in the liquid state. Suppose this is here, system is here, coordinate system is here. But this is the coordinate position. In which form is water stable? Water is present here, is in the vapor form. Suppose my system is here. This is the coordinate position. My system is here. Pressure is this one, temperature is this one. This is temperature, this is pressure. What is the state of the system? System is in the I state. Here you see, if the coordinate is changed, position is changed, then the state of the system also changes. That already you know in the +3 in the phase diagram. So in the water system, sulfur system, also the iron carbon and many other systems are there in +3. You know that if the position change, the state of the system also changes. And this postulate tells the same thing. But here quantum mechanical system means quantum mechanical system means very small area, very tiny, very minute particles. So if the coordinate, that means coordinate means if the position changes, the state of the system also changes. So it tells that the total probability, this is what the postulate number 1 tells, the total probability of finding a particle in all space that is in all possible value. What is the value is? Now minus infinity to plus infinity psi xt psi asterisk xt dx is equal to 1 if we take in x-axis. Psi asterisk xt, this is called asterisk, is the complex conjugate of psi xt. Psi star xt is the complex conjugate of psi xt. So psi xt depends upon the time. So this function psi xt is called time dependent function. Time dependent function. Suppose the system consists of suppose the system consists of n microscopic particles. Suppose this system consists of 5 number of particles, because we take the minute amount, small, very small, classical means bulk amount, quantum means small microscopic particle. Suppose n microscopic particles are there. So what is my psi xt? Psi xt is equal to psi n microscopic. So x1, y1, z1 একটা particle second particle x2 y2 z2 second particle হইল না, third particle x3 y3 z3 third particle হইল না, ಎಂತ ಚಲ್ಬಾ n particle xn yn zn n particle then time. Okay, this is for suppose 3 particles, then psi x1 y1 z1 x2 y2 z2 x3 y3 z3 t for 3 particles. For n particle is such type, and this is called time dependent Schrödinger wave equation. যদি আমি এনতা লিখবা তাহলে এনতা भी হব। যদি মু কইবি psi x খালি x মু লিখবি, এটা কইবি টাইম ইন্ডিপেন্ডেন্ট wave function. Time independent wave function. T will not there. For n microscopic particle, how can I write? Psi x1 y1 z1 x2 y2 z2 x3 y3 z3 xn yn zn. It is not, T will not be here. This is called time independent wave function. So, such a system is said to be stationary state, and psi x is called the stationary state wave function. This is called stationary state, and so if it in such a case the observable property of the system do not change with time. This state will not change. If the time changes, it will not change. It will remain as such. That indicates that it is stationary state. That means it is remains fixed. It will not change with time. So this is what is called the postulate number 1. Similarly, for postulate 2, second postulate tells that the wave function psi xt which is called time dependent wave function psi xt and its first and second derivative, first derivative and second derivative such as dou psi xt by dou x, this is the first derivative, and dou square psi xt by dou s square, this is called second derivative, are continuous. This already हमें पढ़वा करिछे continuous function हमें केनता कहबा. This is called, it is continuous. Finite हमें भी जाना करिछे finite value हमें कहा को कहबा unit 1 को, and single valued for all value of x. For all values of x. Also the wave function psi xt is normalized. The wave function psi xt is normalized. that matlab normalized function, matlab integration minus infinity to plus infinity psi xt asterisk dx is equal to 1. This is called normalized wave function. Here psi asterisk xt is the complex conjugate of psi xt. Psi star asterisk is the complex conjugate of psi xt. Okay, this is the postulate number 2. That means we have to take, if psi xt is some function, we have to take first derivative and we have to take second derivative and we have to see whether it is continuous or not. Already we know from the unit 1 whether it is finite or not, and single valued for all value of x. For all whatever the value you take the x value, we should get, it should be continuous, it should be finite, it should be single value. Then we tell that this is for normalized equation. That means the wave function psi xt is normalized. If psi xt and psi asterisk xt is equal to 1, then we call that this function is normalized. Asterisk matlab, if there is any complex conjugate, matlab suppose x plus iy, the complex conjugate of this function is x minus iy. If imaginary number is there, if sign changes, if we change, then we call that it is complex conjugate. That means this one is the complex conjugate of this function. That means this one is the complex conjugate of this one, or this one is the complex conjugate of this one. If imaginary, if there is no imaginary value, then the sign will not change. Suppose x plus 3y, then it is remain as such in complex conjugate form. If only I is there, the sign will change, otherwise it will remain as such. I will end here. Next class will do postulate number 3.